Welcome. Today, we're going to go on an invisible odyssey. We're going to trace the path of a single piece of data, from the very instant you press the key, through this hidden world of light and code, and all the way back to a screen, in literally the blink of an eye. You've totally done this. We all have. You type out a message, you hit send, and poof, it just vanishes. But, it's not magic. It's actually the start of this lightning-fast journey through a hidden world of signals and code. So let's pull back the curtain and see exactly where it all begins. So the very first step happens right there, inside your device. Before your data can go anywhere, it has to be translated into a language that computers can actually understand. And that language is binary code. It's actually as simple as a light switch. There are only two states: off, which a computer sees as a 0, and on, which it sees as a 1. That's it. Every single thing you do, every character you type, gets broken down into millions of these tiny little on-off electrical pulses. So how does a computer translate something like the number 9? Well, it's kind of like a simple math puzzle. As you can see here, the computer just keeps dividing by 2, and it just jots down the remainder each time. Once it hits 0, it reads those remainders from the bottom up. And just like that, the number 9 becomes 1001, the language of the machine. And this isn't just for numbers. Oh no, letters and symbols get translated too. There's this standard called ASCII, and it basically gives every character on your keyboard its own unique number. So A is 65, B is 66, and you get the picture. The computer then takes those numbers and turns them into binary. So when you get right down to it, everything you type just becomes a really, really long string of ones and zeros, all ready for its big journey. Okay, so our data is now in binary. The next big challenge, we've got to get that string of ones and zeros from your device all the way to its destination, which, by the way, could be thousands of miles away. Our data can travel in two main ways: through wires or through the air. Optical fiber, that's a wired technology, and it's like a dedicated express lane using pulses of light to send data at just incredible speeds. Then you have wireless technologies like WiMAX, which are more like all-terrain vehicles. They can cover huge distances and get to remote areas, even if they're a little bit slower. And you know what? We need both to build a world where someone in a busy city and a farmer out in the country have the exact same access to information. All right, so once we've picked our method of travel, the data needs a map. It can't just wander around aimlessly. In the world of networks, this map is called a topology. It's basically the layout that decides how all the different devices are connected and how data flows between them. So here are a few of the most common network roadmaps. In a bus topology, all the data travels down a single main cable. It's simple, but hey, if that one cable breaks, the whole network goes down. A star topology has all the data flowing through a central hub. You'll find this in most modern offices. And then there's the mesh topology, where every device connects directly to every other one. It's complex, sure, but it is incredibly reliable, which is exactly why it's used for really critical systems, like the internet's backbone. Okay, our data has made the journey. It's arrived at a server somewhere in the world. But now what? We can't just dump it all in a big, messy pile. It needs to be stored in a really organized way so that we can find it and use it later. And this is where databases come in. I want you to think of a relational database as a massive, hyper-organized digital library. But instead of books on shelves, it uses these neat tables with rows and columns to store every single piece of information. So how do you find anything in this giant library? Well, you need to speak the librarian's language, which happens to be SQL. That's structured query language. You use SQL to ask the database to do things for you. Find a specific user's info, update a record, or add something new. It is the command language for data. And here is SQL in action. Check this out. On the left, we've got our original student data. With one simple command, we can instantly sort the whole table by GPA, just like you see on the right. That is the power of SQL, the ability to manage just massive amounts of data with only a few lines of code. So our data has been translated, it's been transmitted, and it's been organized. Now for the final step, presenting it in a way that actually makes sense to us humans. The language for this is HTML, or Hypertext Markup Language. It was created way back in 1990 by Tim Berners-Lee, and it was just a simple way to share documents. But as you can see, it took off, and it evolved really quickly. Browsers like Mosaic made it popular, and new versions like HTML5 became the standard for the entire modern web we use today. So, what is HTML really? Well, it's just a set of instructions for your web browser. This code is like a blueprint, and it's telling the browser exactly how to structure the content. Okay, create a table, now add a row, now insert a header called month, and so on. And here's the result. Your browser reads that HTML code and renders this perfectly formatted table. This transformation from code to what you actually see on your screen, that's the final step in our data's incredible journey. Okay, let's just take a step back for a second and look at the whole thing, the entire journey from start to finish, from a single bit of data all the way to your browser. So first, your key press gets turned into a number with ASCII. Then that number is translated into binary, ones and zeros. Those signals then travel across a massive, complex network of wires and waves. They arrive at their destination where they get all sorted and organized in a database. And finally, a browser reads HTML to present that information right back to you. And here is the most amazing part. This entire unbelievably complex journey, from translation to transmission to organization to presentation, it all happens in the blink of an eye. Every single time you click a link or type a search or send a message. This process isn't just happening for you. It is happening for billions of people, billions of times, every single second. It is the invisible heartbeat of our modern world. And it just makes you wonder, with this incredible power at our fingertips, what are we going to build with it next?